Hello. Uh, First stream. Let's see here. So, today I'm going to be finishing up my update to this 3D Collision Helpers library that I made. And if I finish that, I think, I'll probably work on the thing I'm working on the side, the game thing. I don't know. It's kind of got stuff, but I got sidetracked with adding a Lua JavaScript console to it. But we'll see how that goes. Music too low? I'll have the music up for a little bit. Yeah. Anyways, based on this thing, an article that popped up on Hacker News about rotations in different representations and how to convert between the angle axis rotation and the rotation matrix. And I'm implementing that in my thing here. I've already done the exponential map implementation. I'm about to do the logarithmic map implementation, which has already been, well, thanks to this post. What is this? A blog post? An article? The work has pretty much been done for me. I just need to implement it in code. And this is helpful because I use Raylib for most of my stuff, and when you draw 3D things in Raylib, they expect sometimes for rotation they only allow you to have like let's see, draw some model EX. It expects an angle and an axis to rotate around that axis. And since I have just rotation matrices in my program, this logarithmic map from the matrix to the angle axis representation would make it a lot easier to use Raylib because it expects just the angle axis thing. So I've already implemented the exponential map converting an axis and angle into a matrix, and now I'm going to implement the conversion back from a rotation matrix to an angle axis, and it looks like well, the work has already been done for me, so uh let's see. So, given the matrix, I need to convert it to angle axis. Okay, so getting the angle, I just need to get the trace or the sum of the diagonals of the matrix, rotation matrix. Track by 1, divide by 2, arc cosine the whole thing, that gives me the angle. So sum trace equals mat 3. You know what? I need LSP for this. Okay. Okay, that's subtracted by 1, by 2 arc cosine. I should have a cos. There we go. Which is trace minus 1.0. All that divided by 2.0. Using floats, not doubles. I probably should use doubles, but whatever. That's the angle. The axis is just parts of the rotation matrix. Oh, we need the angle. Okay. Alright. Oh wait, is the thing blocking the view? Hold on. Let me just, move this up here. Here we go. Okay, whatever. Anyway. I need the angle. So basically a vec3 composed of the mat 3 through 2. I'm assuming that's x. No, that's y to s. Hold on. Is R the rotation matrix? I'm pretty sure R is the rotation matrix. Isn't it? Let's see here. E theta u hat is the rotation matrix derived from angle axis. Pretty sure. Yeah, it says right here R is the rotation matrix. Got that. That looks fine. Okay. R32 would mean, well, according to my definition of the mat3 right here, it would be 3 to Y2, I'm pretty sure. Right? Is it column major or row major? I'm pretty sure it's column major. I'll probably have to test this. So Y2 minus mat3 Q3 Z1 Y2 Z1 1 3, so that's E0 minus 3 1 X2. And then finally, what is it? 2 1 and 1 2. Math 3 2 1 is just X1 1 2 Y0. We double check. 3 2 Y2 3 2 1 3 2 1 all reversed. 1 3 D0 and X2 2 1 Y1 X1 Y0 3 2 Okay, I'm kind of getting a little bit confused, but I'm pretty sure I could figure it out with some unit tests. So now I need to see if I implemented mat3 times scalar or vec3 times scalar. Should be implemented. Yeah, okay. So all this times 1.0 f divided by 2.0 f times sine of angle, and that should give the unit vector. Is it a unit vector? I would think it would be a unit vector, but I'm not sure. I'd have to test that. On to the unit tests, I guess. Okay, so axis angle. Is my voice too low? How about this? Is this okay? Let's see. Okay. So, let's see. I just need to test the exponential map first. Let's say pointed in the z-axis, and z-axis positive is pointing out the screen towards you, and negative is into the screen away from you. Right hand rule helps with that. Okay. So let's see. Axis is that float angle. For now, I'll do. Your pi. Hold on. Is there a pi built into this? I mean, there has to be a pi. Literal. This thing. Numerics library. Pi. Constant. There's no tau. What's wrong with my music playback? It keeps on messing up. Oh, that's a little loud. Hold on. Okay. Anyways. There's no tau, which is 2 pi. Whatever. Pi v. Numbers. Hold on. What's the minimum version I'm using? 20. I'm using 20. Okay. It's in 20, so I just import numbers. It's already imported. What am I doing? It's already imported! Okay. Numbers. Namespace std numbers. Okay. Hold on, what's my thing to fix thing? Control A. Let's do this. Pi over 2 is 90 degrees, so I'm gonna be 90 degrees about the z-axis. Okay. Axis angle. And then this is my regular rotation matrix. So theoretically, these two matrices, when multiplying a vector, should result in the same result, because they should be the same angle about the z-axis. So to try that, I'm gonna have to create a vector that's like, I don't know, like literally this. And I just do what? Okay, and now I have these two vectors. You know what? I'm just gonna replace, not use auto. I don't really need to use auto for that. So check float. Okay. So theoretically, this should result in... Okay, the checks have passed. They are the same. They are the same. I'm gonna have to do this for every angle. And for every axis. Why'd I retype that? It's already there. Whatever. Okay, actually, I could just get rid of this part. Do this. Alright. So I've got vector stuff happening. Let's test that. 930 and 931. That's bothersome. Okay, the Y is opposite for some reason. Why is that? It's rotated in the opposite direction. What the heck? Why? Okay, so if it's x-axis, it should be rotating from positive y to 0 and positive z. Wait, hold on. The one. So z and y negative 1 to z and wait, hold on. No, it was z1 y1 originally, which means it was towards out of I can't even talk. Okay, it's just towards out of the screen and up. The rotation about the z-axis should be negative y, but it's positive y for some reason. I don't get it. Why is it positive y? Am I math wrong? Something wrong with this exponential map function? Why is it in the opposite direction? I mean, it is rotating 90 degrees, or yeah, 90 degrees. Just in the opposite direction, so did I get the math wrong here? Did I get the implementation of the math wrong? Be identity plus sine of theta times u hat. Yeah. And 1 minus cosine of theta times u hat squared. Yeah, I got that as well. So, oh, that's a problem. For some reason, this exponential map has an opposite direction of the y of the x-axis rotation. I want to see if it does the same for z-axis, so let me just do the same thing again. Comment this. Z or y-axis. About z-axis. About x-axis. About y-axis. They all failed. Oh no. Okay. What does it say? Oh, no. Okay, so it's 111 originally, and then rotating about the y-axis, it should be going like counterclockwise. If you're clockwise, if you're looking up, it should be going clockwise. So 111. Transformed Vec 0 is using the exponential, what is it? Exponential map. So that's from 111, you change only x and y, x and z. X and z are both 1, that means it's like to the right and out of the monitor. Rotating about y should be to the right and into the monitor. Wait. Hold on a second. Out of monitor, going left. No, it can't be. My implementation is wrong. Is Mat. Hold on, I need to test this with Mat 4. Yeah, let's try to test again. Let's save the Mat 4. It still fails! Oh no! What the heck? Pi over 4? That's 45 degrees. Ain't it? What is Vec A? Positive x about z 80 degrees, it should be y. Yeah, that's this, what? What? Mat A, Vec A. Mat 4, Mech 3 volt. What? Yeah, so this vector is just 1x, 0y, 0z, multiplied by the rotation matrix that goes about the x-axis by 90 degrees, and the result is positive 1y. That makes sense to me, because it's supposed to go from... Because z-axis, if you take your right thumb and you point it in the z-axis direction, the rest of your finger should curl around that axis, and that's the angle, that's the direction of the rotation. It should go from positive x to positive y. And this unit test verifies this. For some reason, that is not what is happening here. I don't get it. Why is it wrong? Do that again. Oh, shoot. They're all z-axis. They're all z-axis. No wonder it's not working. It's a typo, not a freaking... Ugh. Why? Why? Mat 3. There we go. Now this should work. Now this should work. It works! Ah, it was a typo! I spent like 10 minutes, 20 minutes on a typo. Oh. Yeesh. Okay, whatever. Whatever, man. Whatever. Okay. Well, now that I know that it works... I mean... I need to check... I mean, I could test more thoroughly, but I think just each axis testing is good enough. For now. Test rotation matrix to axis angle. How do I test this? I have no helper function to to rotate a vector about an axis. I should probably implement that. I probably should implement that, you know? But I don't remember linear algebra that well, and it's been years. It's been like 10 years since I took linear algebra as an undergraduate. So I'm gonna have to like go through the book again, maybe? Is there stuff about axis angle? Axis angle. I mean, this is like a. Is there? No, it doesn't. There's no implementation details. It's just rotation about an axis, arbitrary axis vector. Okay, okay. I need to do that. To do implement rotating vector with axis angle, so that I can test this. So that this can be tested. So one way is good, the other way I don't have a rotation thing implemented. So that's not ideal, but whatever. That's just how it is. Okay. Okay, so I have all this set up. Okay, what did I do? What else did I do? Added mat 3. Added mat 3 and helper functions related to mat. What else did I do? Implemented conversion from axis angle to rotation mat. Implemented conversion from rotation matrix mat 3 to axis angle untested. That's all the changes. git commit messages. Okay, that should be good. Yeah, I'm using like a temporary key, that's why it's in my home directory. I figured out SSH key certificates, and it's kind of really weird to set up, but pre-stream I set up a key that expires in 2 hours, so I'm using that. And in case the key expires and I still want to push commits, I can just make another key. It's just a little bit unwieldy, kind of. Let's see, I just added a change. Yeah, my mouse wheel is kind of broken. It keeps on I scroll down and it keeps on scrolling up sometimes. I don't know, maybe I need a new mouse. I don't get it. Why my mouse is like this. Whatever. Looks like the unit test passed. That's nice. Okay, so axis angle, I should implement that soon. Spinning cow. Okay, so I'm pretty much done with what I was trying to do with this library that I'm making. Bump the version, I guess. Yeah, okay. Okay, let's see. So, that seems to be it for this thing. So this is a test stream of just programming, I guess. Next stream, I don't know what I'm gonna do. This stream, I'm thinking I'm gonna stop here since I'm not sure. I haven't got much else planned right now, other than I want to work on my game, but my game is closed source currently. I'm not sure if I'm comfortable enough to work on the game in the live stream. Maybe I'll open source it. I don't know, or I can work on something else. That's something I don't know. So if I'm going to stream again, I'm probably gonna I'm probably gonna just I'm just gonna figure out what I want to do that's not closed source, and then work on that next stream maybe. I don't know when that's gonna be. That's just what I'm gonna do. So that's it for now. So that's it for the stream. Thanks for watching. And I hope to see you again when I figure something out for the next stream. Because I want to just, I think streaming helps with programming. I watched a few other people live stream before, like Jonathan Blow working on his game engine, or game Sokoban, or whatever it's called, or Asahi Lina working on Linux on OS X machines, M1, M2, development, stuff like that. And I realized, oh, if I stream while I program, I talk about, it's like the rubber ducky problem thing, you know, like the, hold on. There's a thing. Rubber ducky programming. Rubber ducky debugging. It's basically a method of debugging code by talking about it. And you usually talk to the rubber ducky, and for some weird reason, this actually helps with debugging, because you re-go over everything about your program, and you realize, oh wait, my assumption about this might have been wrong, and then you figure it out, or something. Basically, with debugging, if you're stuck and something's broken, the best thing you can do is to reevaluate every assumption you have, and this kind of technique helps. And I think streaming is somewhat equivalent to that. So yeah, that's what I think I'm gonna do for other programming stuff. Just stream it, and it will help me rubber ducky program the thing I'm making. So thanks for watching, see you next time, whatever, bye.